Hello everyone and welcome back to our channel. Today, we're going to give you a tutorial on how to solve the mean and variance of the sampling distribution of the sample mean. So if you're having a hard time on coping up with this specific lesson about mean and variance of the sampling distribution of the sample mean, then you're in the right place. First, let's talk about the importance of the sampling distribution. Since populations are typically large in size, it is important to use a sampling distribution so that you can randomly select a subset of the entire population. Doing so helps eliminate variability when you are doing research or gathering statistical data. Furthermore, understanding statistical inference is important because it helps individuals understand the spread of frequencies and what the various outcomes are like within a database.
To begin, let us first identify the elements of our population. 5 participants competed for a weightlifting competition to represent the country for the Olympics. The weights they lifted measured in kilograms. The first participant lifted a total of 49 kilograms. The second lifted a total of 67 kilograms. The third lifted a total of 64 kilograms. The fourth lifted a total of 55 kilograms. And the fifth lifted a total of 50 kilograms. If a sample of 3 participants is selected randomly to participate in the Olympics, what is the mean and the variance of the sampling distribution of the sample mean? Suppose the population is composed of the participants who competed for the weightlifting competition. The weight they lifted 49 kg, 67 kg, 64 kg, 55 kg, and 50 kg. Step 1. Compute the population mean. In order to get the mean of the population, just add all the elements of the population and divide it by the total number of the elements of the population. After adding 49, 67, 64, 55, and 50, we have the sum of 285. Divided by 5, we have the total of 57. So the population mean is 57. Step 2. Determine the number of possible samples of size 3. Using the formula shown in the screen, first thing we must do is identify the number of population as well as the sample size. 5 factorial is equivalent to 5 times 4 times 3 times 2 times 1, while 3 factorial is equivalent to 3 times 2 times 1, and 2 factorial is equivalent to 2 times 1. What we did in this solution is we just simply remove 3 factorial and remove 3 times 2 times 1 from 5 factorial. So 5 times 4 equals 20 and 2 times 1 is equals 2. So 20 divided by 2 is equals to 10. So there are 10 possible samples of size 3 can be drawn. Step 3. List all possible samples and their corresponding means. To solve this, just simply add the samples. Example, 49 plus 67 plus 64 is equals to 180, and just simply divide it by 3. So 180 divided by 3 is equals to 60. So the sample 49, 67, 64 have a corresponding mean 60. Step 4. Construct the sampling distribution of the sample mean. So we have 3 columns here. The sample mean, which is the value of the random variable x, frequency, and probability. So these are the sample means: 51.33, 54.33, 55.33, 56, 56.33, 57, 57.33, 60, 60.33, and 62. And for the frequency, we will just get the number of times the sample means occur. Step 5. Compute the mean of the sampling distribution of the sample. In order to get the mean of the sampling distribution, we just simply multiply the sample mean by the corresponding probability. Example, 51.33 times 0.1 equals 5.133. Repeat the process until the third column is complete. After that, you need to add all the results and get the sum of it. So 5.133 plus 5.433 plus 5.533 plus 5.6 plus 5.633 plus 5.7 plus 5.733 plus 6 plus 6.033 plus 6.2 equals 56.998 or 57. Now we have the mean of the sampling distribution. Step number 6. Compute the variance of the sampling distribution of the sample means. What you have to do first is subtract the population mean from each sample mean. So 51.33 minus 57 equals negative 5.67. Repeat the process until the third column is complete. Next is, in third column, x minus mean squared. Just simply square the answer. Example, 5.67 squared equals 32.14. Repeat this process until you complete the fourth column. For the last column, just multiply the result of the previous column with their corresponding probability, then add all the result. So now, we have the variance of the sampling distribution, which is 8.866 or 8.87. That's all, and I hope you learned something from this video. Thank you for watching.